So one of the biggest tasks that we are asked to do in this unit is to find the equation of a line. To find an equation of a line, you always need two things. Okay? One, you need the slope, and two, wow, that almost spells any. There we go. And you need any point. If you have those two things, you can find the equation of a line. Now, there's going to be some times that you can find it even quicker if you're given more specific things. And that's what we're going to look at first, some specific things. If you know the slope and the y-intercept, you do know a slope and a point, but the point you know is a specific point. And then you can plug things right away into y equals mx plus b. So here, it has a slope of negative 2/3 and a y-intercept of 5. Well, if you want to write the equation in this form, you need to, I'm going to go fancy here, change the colors of these letters to purple. I really like purple right now. It's nice. It's doing well. We need to find numbers that have to go in for those purple values. In an equation of a line, there's always a y, there's always an x, and then there's numbers. No matter which form you put things in, the general form, the point slope form, or y equals mx plus b, there's always a y, there's always an x, and the rest are numbers. So in this case, the question is, if I have this form, do I have things that can go directly in for those numbers? Yes. I can say y, that's purple. I want to go back to blue. Oh, still purple. There we go. Y equals, and then I know m is negative 2/3. And I know that b is 5. So I can plug in values for m and b. Finally, so we found the equation of a line. Often at the end of these questions, they say which form they want the equation of the line in. Do we have it in the right form? No. It says give your answer in general form. So general form, no fractions, one side equal to 0. Whatever number is in front of x needs to be positive. So first of all, do we have fractions? Yes. We're dividing by 3. What's the opposite of dividing by 3? Multiply by 3. So we multiply both sides by 3, which means every term will get multiplied by 3. I will then have 3y equals, here, multiplying by 3 and dividing by 3 cancel out, because that's the whole purpose of multiplying by 3. 3y equals negative 2y plus 15. Whoa, easy mistake. I don't know how that changed into a y. It was an x before. It should stay an x. We've gotten rid of our fractions. Now we need to make one side equal to 0. We need the coefficient. Have you heard that word before? Coefficient is the number in front of. We need the coefficient of x to be positive. So right now, the coefficient of x is negative 2. So I'm going to move everything over to the left-hand side. Now, probably in grade 9, did they make you write plus 2x, minus 15, minus 15? Maybe they made you do that. You can do that still if you like to do that. But if you know that that's what you're doing in your head and your next step just looks like this, add 2x to both sides. Subtract 15 to both sides. And you just go to there, that is fine. Okay? But if you still like to show I added 2x to both sides, I subtracted 15 to both sides. That's fine. And so now we've written it in general form. So this is a specific case where you were given m and b. And if you're given m and b, it makes a lot of sense to use y equals mx plus b, because you can very quickly put in the numbers that you need. Okay? We're going to look at now the more typical case where you have, oh, not yet, one more example. We'll do example 2, and then we'll look at the more typical case where you have a point and a slope. So here, write an equation of a line that has a slope of 2 and a y-intercept of -7. I'm going to get you to do this one on your own. And write your answer in general form again. Okay. If you are given a slope and a point, okay, this is our main goal, to find an equation of a line. These are the two things you need. So let's say you are given what you need. Then you have two methods in which you can find your equation. You can either use y equals mx plus b, or you can use the point slope formula. Well, how does this work? Write the equation of a line passing through the point. That's one of the things that we need. And having a slope of 2. That's the second thing that we need. We can write the equation of this line. Give your answer in slope-intercept form. So there are two methods to doing this. I'm going to do method 1 here, and we'll leave space for method 2 here. And whichever method you choose is up to you. Okay, it's not going to say, find an equation, use method 1. There's never a equation. Sometimes they do that, right? Sometimes you get a question that they say, I want you to use a certain method, so we're going to test that. But with these questions, you always have the choice. So your method 1, oh, I want to use purple again. Okay, just to remind us that our goal in method 1 is to get a number for m and a number for b. The problem with method 1 now is we don't know the y-intercept. We just know a point. In fact, the only thing we can do to begin with is say, I know that m is 2, but I don't know what b is. So I have a problem to begin with. So we plug in our slope, and once we've done that, we think about, what does an equation of a line do? Right? An equation of a line, you could put in a table of values, and you could find out what x is and what y is. And whatever points that are on that line, this is an important idea about equations and graphs in general. If a point is on the line, it makes the line true. Meaning that if you plug in the x-coordinate and the y-coordinate, your equation will be equal. If a point is not on the line, it will make your equation untrue. You'll get like 5 equals 10. Not true. Then that point is not on the line. This is a key thing from now all the way to grade 12. Points that are on a line make the equation true. Next semester, you're going to have parabolas. Points that are on the parabola will make the parabola equation true. So if we know that that point is on the line, that means when x is 3, y has to be -2. So if I plug in 3 for x, then I know that the y has to be -2. I still don't know what b is. So maybe we want to add here little notes of what we did. We plugged in the slope, and now we plugged in the point. So later on, when you're looking back at your notes, you're like, oh, that's what I did. You never have to write the black part down when you're showing your work on a test or quiz. It's sort of obvious that that's what you did. But when you're reading your notes later, you might say, what did I do? Why did I do that? Oh, I knew the slope, so I plugged that in. And now, since that point is on the line, it makes the equation true. I can plug in the x value and plug in the y value. And then I look at my equation and say, hey, there's only one thing I don't know. I don't know the value of b. I wonder, could I get b all by itself? Could I rearrange this so that I just have b on this side? What would I have to do? I'd have to subtract 6 from both sides. Then I would just get minus 8 on this side. And now I figured out b. Once you've got that, you can write the equation. We know that our slope is 2. We know, oops, I can write my b value is minus 8. So I knew my slope already, and by plugging in the point, I was able to find what the b value was, and so now I can write my equation in y equals mx plus b form. Yes? If it's true, then the equation's equal, and then you could solve for b.
But how do you know if it's equal since you don't know what b is?
You know that it's equal because you were told in the question that the line goes through that point. That's the idea here, that if a line goes through a point, it makes the equation true. And if it makes the equation true, that will allow us to figure out what b is.
So this only works if we know for sure that that coordinate is true.
That's right.
Okay.
Yeah, this question would not be possible if it said, write the equation of a line with a slope of 2 that doesn't pass through the point. Well, that doesn't help us. We know what line it isn't, but we can't possibly find out what line it is. So again, if we go back to the very beginning of our notes here, what we wrote right at the beginning, how to find the equation of a line, you need these two things. You need slope and any point.
When you get a chance, can you look at the folder for grade 11 essentials? The French exam's there, but there's no English version. So I'm just wondering if someone never put it in there.
Oh, okay. The old one? Okay.
Like the actual exam for this year, there's only a French version and not English. I thought that was kind of curious.
Okay.
So when you get a chance.
So method two says start off with y minus, and I'll put things in purple here again, So method 2 is the point slope form. The point slope form says if you know a slope, you can plug it in. If you know a point, you can plug it in. Well, we know both of those. So as far as writing in our first step, we can do both at the same time. Plug in the point and slope. If I do that, maybe above my point I will write x1 and y1, just so I make sure I plug in the right values in the right place. Y minus, and anytime you put in a negative value, I like to put it in brackets just to make sure that we don't screw up on our signs, equals m, which is 2, x minus 3. So we plug in our slope and we plug in our point, and we labeled above our point so we make sure that the negative 2 goes in the right spot and the 3 goes in the right spot. And now what we need, because it asks to have this in slope-intercept form, we just have to rearrange it so that it equals y equals mx plus b. So what does that mean we need to do? Well, this 2 has to be distributed. So we will have y negative 2 is plus 2 equals 2x minus 6. How would I get the y by itself? Subtract 2 on both sides. So notice we get the same answer with both methods, which is good, because if you started getting different answers with different methods, then you would have problems with one of the methods, hopefully, not both. So we get y equals 2x minus 8 in both methods. So what are some advantages and disadvantages of both methods? Okay. Method number 2. The advantage is you can plug in everything right away. And it becomes very obvious what you need to plug in, because you have a point and the slope, and then you just have to rearrange it. So for that reason, a lot of people like the point-slope form, because as soon as you get the two things you need, point and a slope, you can plug it into the equation right away. Okay? Almost always, the question will ask you to write it in either general form or slope-intercept form. So the point-slope form of equation, you often have to rearrange to some form in the end, which isn't too bad, but it's something you have to do. So advantages of the point-slope is you can plug in things right away. Okay? Method 1, y equals mx plus b. The advantages of this one. Okay? This method, for one, you will find that at the end of this year, you will have y equals mx plus b memorized more than you will have y minus y1 equals mx minus x1 memorized. It just has a nice ring to it. So you will remember the formula quicker. So that's an advantage of method number 1. Another advantage of method number 1 is it's a method that's used later on. You do the same idea in parabolas. You do the same idea in graphs of sine and cosine when you do it later on. So you use this idea of plugging in the point that you know for x and y often. And so for that reason, it's nice because you're going to use this strategy again. So I do find if I ask my grade 12s which method they tend to, when they're in grade 12, they tend to go towards method 1 because it's easier for them to remember. And because it has connections to other things. But both of them are very good. Okay? The hard part about method 1 is this step right here when you plug in the point, because it requires that you understand how an equation of a graph, of any graph, works. That when a point is on the line, it makes the equation true. So you can always plug a point in to figure things out. And it doesn't matter which point you would pick. If we picked another point on this line, it would still give you the same y-intercept. No matter which point you pick, the b value will always be the same. So if you had 2 points and you're like, well, which one do I use? It doesn't matter. Any point that's on the line will make it true. Often, if you're asked to write it in y equals mx plus b form, the nice thing about this is that it's already in the right form when you're done. So both of them have advantages and disadvantages, and both of them are good to use. Okay, I would like you to do this one in both methods. Or what do you think? Do we need to do one more together? Okay, we'll do one more together, and then I'll get you to do 5 and 6 on your own. So one more together with both methods. Method 1. Y equals mx plus b. And I'll color code it as I'm going along as well. We can plug in our slope because we know that already. Y equals -3. Whew, I'm getting good at switching colors. Y equals -3x plus b. And then we can plug in the point. Again, what is written in black, you would not have to write down on a quiz or a test. You just have to show your work. But when you're looking at your notes and studying, sometimes those things are nice to have there because you're sort of like, you know, sometimes it can happen, probably sometimes too often, you're looking over your math notes and you're like, I have no idea why I did what I did, where we got this, and what's happening. So sometimes these little explanations are nice. It goes through the point -5, -1. That means when x is -5, y is -1. And now, can we get b by itself? Yes, this is 15. Subtract 15 on both sides, and you get b is equal to -16. So we can write the equation. Y is equal to, we now know that, we knew that the slope was -3 before, and now we know that the y-intercept is -16. So you can write plus -16 like I did there, or you could just write -16 if you want to put that plus and minus together. This question, however, says give your answer in general form. So we have to rearrange it so that it looks like this. What do we have? No fractions. The good thing is we have no fractions to begin with. We need the value in front of x, or the coefficient in front of x, to be positive. Right now, the coefficient in front of x is -3. So I'm going to add 3x to the left. I'm going to add 16 to the left. And my final equation is going to be 3x plus y plus 16 equals 0. Method 1, y equals mx plus b. So you plug in your slope, you use your point to find b, then you rewrite your equation, and we had to rearrange because it wanted it in a different form. Method 2, point-slope form. So if we write out our formula, we need to put in a value for m and for our point. And above your point, you can write, I know this is x1 and this is y1, so now we can write our equation y minus a -1 equals m, which is -3, x minus -5. So I plugged in my values. I put my negative values in brackets. If you wanted to, I could put this one. This one could be in brackets as well. So what did we do? We plugged in our slope and our point. And once we've done that, now we just need to rearrange. With the point slope formula, the first thing you're going to do when you rearrange, you're always going to distribute that negative. So that will give me y plus 1 equals negative 3x. Okay, look at all those negatives. Whew, what's going to happen when I multiply negative 3 multiplied by the negative 5? Positive or negative? Negative. Because this will be a positive 5, and then it gets multiplied by the negative 3, which will be negative 15. We now rearrange things so that the x is positive. So I'm going to add 3x. I'm going to add 15. So if we look at this overall, it looks like in this case method 2 is shorter. Okay? But again, I like to circle my final answers. It's a really good thing in math when you're doing your math work, because sometimes your math work starts to go all over the page. To put a circle around your final answer to show that you know that that's your final answer is an important thing. Sometimes people don't circle their final answer because they're not sure what their final answer should be. So they just say, hopefully it's on the page somewhere. All right, so there are 2 more there for you to try, and then you can, if you finish them early, you can start worksheet number 7. Once you get your answer, you can check with me.